Okay, some of you know me, but later on you will know me better. I am Satya Rao, coming from Switzerland, the Indian touch, and I will be presenting next speaker, Professor Neeraj Suri. Again, the name says is the Indian root, but I don't know how to introduce him because he has got a multicultural, multi-passportal, multi-areas of technology involved with him, and also working multiple places. So officially, he is in the University of Darmstadt as a professor. I was working with him on security area. Some people are working on digital big data. Some people are working on privacy, societal, whatnot. So it is very difficult to introduce him. That is why, as Professor Javadi is always a clever man, he asked me to introduce. So he can get away from the problem how to introduce.
Clever man disappeared out.
Exactly, that is right. So because he is much more cleverer than Javadi, so that is why he wanted to transfer it to me, not to talk too much. So again, he is also an expert in our EUINCOOP project as well, as an advisor to what we do, to judge what we are doing, and to provide inputs from his thoughts, what is happening for the world, what he has seen. So he is involved with both industrial, as academic, and research, all those things. So Microsoft, Texas, I don't know, so many. So he will tell if I don't know much, or he has to tell more about it. So I will not give you more than what is needed. Thank you, Neeraj.
More than sufficient.
Okay.
Do you need this, or I can just talk loudly?
That is why. Okay.
All right. So can I see my slides up there? That might be the easiest.
Yeah.
All right. So while the program mentions some interesting things about parallelization and lots of programmability I'm supposed to talk about, I have no idea how those words got into the program. So what I'm going to talk about is mostly, actually I'm going to resonate a lot with Professor Kinsha gave in his talk, and you'll see a lot of those issues coming up again, hopefully in the form of answers, or at least some pointers to answers rather than questions. And I'm going to be talking mostly about systems perspectives coming from the European side. I will not particularly talk about high performance computing, which Professor Mendelssohn will be talking later on in the day. So about a month back, there was a meeting with the Indian Cabinet Minister for Science and Technology and the Indian Cabinet Minister for Telecommunications, Sewal, and the heads from DST, where I was part of. And the purpose was to figure out mutual cooperation areas. So a lot of the things that I'm putting out here comes from that meeting. So let me just give you one simple perspective slide, and then I'll basically amplify lots of different aspects around it. So as the European Commission is setting up its so-called vision for the next 15-20 years, so if a year has 365 days, the Commission usually has 1,000 visions based on which person has authority at that time. But at least 3 simple strategy drivers are coming again and again, and we can discuss them later as they come. The first one is the one that really concerns most of you, actually most of us in the computer science area, and it's a very interesting choice of words which should attract a lot of people. Heterogeneous networked service and computing environments. It's loaded with buzzwords, but computing environments and service and heterogeneity have become first-class citizens, including networking. And if you look at the topic areas they're trying to cover, it's everything under the sky you can think of. The second one, which is equally interesting, is e-infrastructures or mobile infrastructures. And the single highlight I want to emphasize out there is trust and security have become first-class citizens, but much more important, usability has become an issue. Earlier, people would be happily developing whatever they liked, and usability was, it's nice to have something. It's becoming a first-class citizen. The third one fascinates me. This has actually gone non-technical. This is basically saying we have tons and tons of data. What are the non-technical issues about data? What are the liability issues? What are the governance issues? What are the management issues? What's the cost of security or something or the other? So this is the profile that you will see appearing again and again. Having said that, most people in their talks give an outline of what they're going to talk about. I give a reverse outline of what I'm not going to talk about. So I'm not going to be talking about application areas in this talk. I'm not going to be talking about any application themes, multi-core. So Satya is looking very worried because these were all the things he wanted me to talk about, and when somebody tells me to talk about something, that's the last thing I'm going to do. So Satya, this is specifically for you. I will not be detailing it. And he also wanted me to talk about Framework 7 projects, and I'm not going to talk about those as well. But thanks, Satiris, I appreciate the confidence. But I will give a landscape picture. But what I thought was more interesting was, rather than talking about the past, so for me, application area projects are in the past, was more to articulate what's the technology thinking going on behind the planning for the Commission in terms of frameworks. And there are two things that are dominating the European Commission's interest. One is the Internet of Things, and it has all the things about e-mobile services, healthcare, education. And the second one, like it or not, is the cloud or the e-mobile infrastructures. Now, I've used the word frameworks out here. What used to happen in the past was people would come up with a favorite topic, wireless sensor network, security, high performance computing, and each one of them would basically either fit within a call for proposals, or wouldn't fit within it. And it used to be you would end up with thousands of different projects, and you would end up with 50 projects in the same area with no rhyme and reason. So you really were not getting coverage of the issues you really wanted to be covered. So what people started doing over this particular set of planning for the next so many years is kind of saying, let's define the context in which we want to develop technologies. And Internet of Things and cloud are the two big context areas. And then you will see within each of this context how the different technologies people want to develop fit in. And that's exactly what I'm going to do for the rest of the talk. I'm going to take the Internet of Things. So in each one of these areas, Internet of Things and clouds, I'm going to give you the conceptual, the abstractions that are driving these frameworks. Then I will translate what are the technical areas behind these abstractions. And then just to keep Satya happy, I will give a glimpse of the different projects. And I have swiped the slides right from your roadmap document, but you'll find it has a lot of value, and I'll amplify that. A lot of you might be wondering that things like high performance computing and supercomputing did not figure in that list. The Indian side was extremely interested in having it as a standalone topic. The European side considered it to be an enabler within the cloud and data management. I think it's an issue of interpretation. It's a very high profile area, but you'll see later on. And again, Avi will talk about it. So as I said, for each of the areas, oh, by the way, you're welcome to interrupt me anytime during our talk, and I also don't cover most of the things that are right on the slide. So either way you want to interact is just fine.
So when you talk about EC frameworks, are you talking about some particular government body, or is it just
so this is the ICD body, which determines about $5 billion of funding over the next so many years, and they come up with thematic areas where they're going to do funding. In the current calls, it used to be there's a unit called embedded computing system or just computing system. There's a unit called trust and security. There's a photonics unit. There's a computational unit. Each one would come up with their own favorite calls of the topics they wanted to cover, and they would end up with overlapping responses, but each one of them would fund it itself. Now they're trying to homogenize the process by saying, let's define the areas, then we'll go about finding what the issues are. So it's trying to kind of saying, let's not refund the same things again and again coming from different emphasis. Let's have some common sense behind it. But again, this is a EU vision, and again, vision changes from day to day. So as I said, in each of these two areas, I'm going to give you the conceptual abstractions driving why these frameworks have appeared, and then I'll give you the areas. So let's look at a very simple one on Internet of Things. And on top are all the buzzwords that you would like to hear out here. Open, unstructured, diverse, mobile environments. So let's look at the issue, all right? So these are the rough parameters. When you're dealing with any kind of unstructured environments, what do you think about? Structure of the environment. I'm talking about Am I talking about an ad hoc environment, or I'm giving you a very focused environment for, let's say, matrix multiplication for the heck of it, or a very clean architecture in a very structured manner? I'll look about the degree of heterogeneity or homogeneity that exists. Am I making life simple by having similar? So when people talk about parallel processing is a very homogeneous environment. You would like to have identical cores as much as possible so you can simplify your programming constructs. But in reality, if I give you billions and billions of devices and entities I'm going to connect, homogeneity is probably the last thing I'm going to get. Similarly, the aspect of mobility comes. Life is easy when you have lots of static sensors. It gets harder when mobility is there. Number of entities is an interesting one. If I have a huge number of entities in any of these unstructured environments, life is actually easy. I have high connectivity, I have high bandwidths and all that. And this is how the classical Internet of Things started developing. Let's deal with very high structuring. Let's deal with homogeneity, very little mobility, high number of entities. This is where the world started in this area about 15, 20 years back. And people have been gradually trying to relax, let's say going from static sensors to low speed mobility, going from low CPU to basically saying we're going to have a whole range of high performance CPUs and all that. The intent of Internet of Things is basically to take it all the way to the extreme right by saying we're going to have a very low degree of structuring, we're going to have a very high degree of homogeneity, very high mobility, and for number of entities I've written diverse. But the actual reality is the hardest problem for us is when the degree of the number of entities is actually very low. If things become very, very small in a certain environment, you do not have enough attributes to make anything out of it. So this is defining the new challenge area by saying all particular permutations and combinations connecting it. Self-repairing system, high mobility, heterogeneity. You can populate it. This is not a comprehensive list. But this is just to give you an idea that instead of just calling it the Internet of Things, there have been attributes which are now being identified by saying, this is what we would like to start addressing as a composition. And it's that composition which now says, this based on this IoT spectrum, this is what we would like to focus on. Now, there's a very little syntactic thing that I have added up there which is underlined, wireless sensor and activation networks. People used to think of Internet of Things as purely wireless sensor networks. Now it's coming to the point, you do not only have lots and lots of entities, they are mobile, they are hybrid, they are autonomous, and they're responsive. So when you were talking about robots and all that, a lot of this is coming back to you actually have them back inside the loop. So, but wireless sensor network is a key area. Activation networks has become a standalone area, and mobile computing in all its dimensions. Once you identify the environment like the Internet of Things, then you identify the focus areas, then you find most of your favorite technical topics follow procedurally out of it. And let me amplify some of the things which are attracting a lot of attention right now. Obviously, the whole range of embedded system sensors. Now there is so much computational power available that this thing has become a standalone topic. So aspects of feature performance. And the thing which I wanted to highlight is power management. This has become one of the hot issues. Now you can populate a place with tons and tons of sensors, but if you don't figure out the power management issues, in this case this is low power management, you have a whole bunch of junk out there. Then functional attributes, you will see again, it's not simply defining a new wireless sensor or a new mobile network. It's based on certain attributes. You would like high degree of scalability. You would like heterogeneity. You would like mobility, and you would like them to be hybrid. And hybrid is becoming a brand new area. I mean, we started from classical computer science with discrete elements, and now you're saying discrete time and continuous time have to mix and match and work. We don't know how to handle it. So I work in the area of formal verification. We don't know how to handle formal verification in continuous time, but now this is one of the requirements. Connectivity, so Sotiris, this should make you happy. This is the big area, but network and middleware stacks are no longer separate topic areas. They come within a context. high mobility, heterogeneity, high density, all of those kind of things, and then what are the issues in the network stack. Mixed criticality integrations. Now, people who work in the automotive aerospace have always had to do these kind of things. But now it's getting to be, you have an Internet of Things. How do you go about classifying what the different criticalities is and how do you handle them? And this is what will now start going into the enabling technologies. When people talk about virtualization, it's now an enabling technology which will help you obtain mixed criticality integration in systems. So a proposal just for virtualization is not particularly attractive anymore. But virtualization in a certain context to provide something is extremely exciting. And then this leads me back to the most important topic that is coming out, which is system of systems. It's no longer your favorite system that you're building out here. You're integrating, you're doing compositions. So when people talk about smart grid or any of the critical infrastructures, what exactly are they? System of systems. So now you're not only talking of system of systems, you're talking of systems of infrastructures. And nobody has a clue how to integrate humans into the whole system of systems. So we have this very convenient analogy in our mind. We'll figure out the technical issues and combine it. The user is actually, most of the cases, the driver behind the whole thing, and we do not do enough cognitive modeling. So having defined a framework which is Internet of Things, extracting the focus themes out of it, and then you have your classical stuff, all your enabling technologies, hardware, software design, verification, validation, analysis techniques, use cases, applications, test beds. Now, if you notice, applications is no longer the main driver. It is certainly a key driver, but it's now a consequence. These are the properties you want. These are the applications that will emerge out of it. Just to make you happy, here's extracted from one of your roadmaps. No, but this is an interesting one. I usually do not like to describe any of the projects. These are projects which have already, the ideas were defined years ago, they're up and running. I don't particularly care about the details of each one, but what interested me more was the decomposition Satya and Sotiris had done to classify things into the embedded framework, into the generic purpose computing, the data centers, and then defining the enabling technologies. This is a very good way to structure technologies to meet a certain framework rather than the projects inside. And Avi will talk about HiPAC, and there is this Artemis and Nessie, the two of you can provide enough guidance. But this is the structure I am advocating very strongly, not only to the European Commission, but also to the National Science Foundation, whose board I sit on, that think of the conceptual elements driving a framework, then extract technology out of it. So let's switch to the other one, which people get excited about. By the way, I work in this area. I still have no clue what people call the cloud. Each person's definition is a different one, so it's just a question mark as far as I'm concerned. You can call it the data infrastructure, you can call it the cloud, you can call it a large-scale distributed system. I fundamentally don't care what the cloud is. But what I do care is that if you decompose the cloud, and this is where I start resonating with the things Professor Kincha was saying, it's a very simple set of abstractions that come out of a cloud. What exactly do you do in any data infrastructure? You acquire the data, transport the data where it can be meaningfully processed, you store the data, and then you either do data management or usage. If anyone has any other abstraction they would like to put, I'd be happy to add it. But it's not important what your technology element is. The cloud is hot right now. In 10 years' time, something else might be hot. But this is not particularly going to change. And this is why if someone is reading what I've written out here, my sole interest is to find the building blocks and interfaces to develop solutions that are domain and technologically invariant. That's where technology advances, not just by saying, I mean, most of us have been doing network distributed systems for years. I cannot distinguish between that and a cloud. For me, a cloud is just a larger, unstructured environment where I can get some more fancy attributes. But I'm not going to change those abstractions. And I'm going to go through some of these abstractions in singly and in combination, and you'll see all your technology areas will emerge out of it. So let me take a crack at it. Data acquisition actually relates a lot to the Internet of Things in terms of the wireless sensor networks and mobile, except if you start thinking that the cloud is an ecosystem. The cloud, by the way, is a meaningless word, which in most people only refers to the cloud fabric, the distributed protocols. But to make it work, you need a whole bunch of middleware support that goes around it. And fundamentally, what exactly is this fabric doing? It's giving users and edge devices and edge networks the ability to interface back with the fabric and get higher order services. So all your classical aspects of wireless sensor network starts appearing in devices, edge networks, and users. And since I'm talking about data acquisition, no one is saying that data only has to be acquired at the sensor levels all the way. Each layer, this is what I call the data wedge. Each layer requires input of data in the semantics appropriate for that layer. So you're dealing with multi-layer data acquisition. So let me define it progressively. And I'm going to combine acquisition with dissemination, which is the natural progression of collecting data to do something. So you have your, so these are also the technology areas which go into calls. You have your favorite stuff in sensors, already discussed that in the IoT. But now you have all the attributes for your interfaces to the device interfaces, and you have all the aspects of dissemination on data delivery with energy requirements, with reliability requirements, with timeliness requirements. And instead of calling it quality of service, the word people start using is quality of information, garbage in, garbage out. So how do you go about defining your quality of information to drive this environment? And again, all your favorite topics are processing models, pre-processing, post-processing, network partitioning, wireless sensor actuation networks, they all go in. The next level of this interfaces is device to network interfaces. And all your mobile transaction models go into it. But now there's a beauty involved out here. You're not talking of classical mobile transaction models. You're talking of really large-scale heterogeneous models where disconnects, low reliability, timeliness attributes are all functions you need to provide to get something meaningful out of it. All of this relates back to network stacks. Network stacks interact with software operating middleware server architectures. You have the entire spectrum of distributed computing sitting right there. But now it's in the context of data acquisition and dissemination. So at the bottom, I've written the enabling technologies. And again, ... will literally fill all of them. Again, virtualization comes in right here as layers. Concurrent programming will all fit into the middleware stack. Anything that you really like will actually come in very easily out here. But the most interesting one, which is cloud specific, is now becoming the data access, storage, and management. Data is wonderful, but if you don't know what to do with it, nothing really comes out of it. And three big conceptual areas or themes are driving this framework. Needless to say, you combine lots and lots of resources to get something useful, so performance is one of the key elements that's driving it. So I'm not going to elaborate, but the HiPAC one will give you all the aspects of multi-cores, programming, all that. I just put it under enabling technologies of architectures and tools. The second one, which was briefly mentioned in the previous talk, is again a first-class citizen right now, is data accountability. We create all this data, but what's the ownership of this data? Who defines the access control on the data? Who defines the storage policy on data? Data is no longer stored locally. So when Google stores its data in India, does the liability become the Indian laws or something else? And people actually take advantage of it. You basically store data where in different countries where there are different access control policies. Again, who's doing the governance? Who has the liability? Who, on the right-hand side, I've written out there, who has the data ownership and the digital rights? So these have become extremely strong topics, but they are now emerging under the context of data storage and data management. And the biggest of these topics which is coming around is basically the trust stack. So again, data is useful if you can trust it. So why do you use your cell phones or the other? You don't use it for the functionality. Of course, you do use it for the functionality, but you wouldn't be using your cell phones if it would be dying on you every 30 seconds, rebooting, not having connectivity or the other. You trust it to do a certain service meaningfully. This is what creates the usability of that entity. But if you start looking at trust in a very holistic sense, now you're dealing with trust all the way from trusted people, trusted data, policies, networks, devices, whatever you have. And again, it's a trust chain. So now start linking it in your mind. On one side, I'm making my ecosystem larger and larger by saying the cloud is multinational, it's as big as you can think of, it's scaleless. That was one of the words I had in one of my slides. On the other hand, I want extremely structured properties of trust and across a very diverse track. It's a difficult problem. But now there's a context behind it. So when people ask, is that, again, I'm going to pick on virtualization, that when people are looking for a collaboration topic, virtualization is a great technology. But if you want to contextualize the technology under, let's say, trust in the cloud, then virtualization is a technology that's obvious. So the context drives the technology. This is the main message I'm trying to communicate again and again. And here again, I've talked about trust. I'm going to link it to a domain of critical infrastructure. Let's say the banking infrastructure. This is something which didn't exist, at least the mobile banking a few years back, but now it's a common theme. Now this is also a theme which requires sensors, networks, protocols, policies, data ownership, identity management, all of these kind of issues. The context, the application of the big applications, whether it's critical infrastructure or something, are now defining the technologies that you're seeing. So again, this is a whole profile of projects, but the ones in the red are the projects that I'm part of. But again, projects are not the important aspect. These attributes defining what aspect, whether they are network or policies or privacy, identity, or core technologies like biometrics, are far more important to identify within this data space. Again, if somebody wants details, I'll be happy to provide it, but that's not the talk I'm doing. Right? So coming to what the two of you had asked me in terms of collaboration perspectives. So these are my opinions. You can agree or disagree. And my opinion is you can always come up with any amount of innovative solutions. You can put your favorite approach. But the value, I think I was overhearing a conversation Satya was having with someone, that why should the Commission go for somebody outside the European Union? What's the value? The value is not in your application. The value is in the core technology. So when you talk about security in the power grid, I can think of having a repository of threat patterns which could be very global. Even if you connect across one other country, it has value. When you talk about stuckness or something, it's a threat pattern which someone else has seen. Therefore, that can be shared in a repository. Similarly, when you do mobile transactions and all that, all of you use Visa cards and MasterCards on your travels. That's mobile transaction as far as it gets. So what's your data ownership and accountability based on that kind of access? So this is what I really advocate in terms of collaboration. This is amplifying my previous slide. Go for technology. Technology is very easily customizable to match your local interest. Let me give an example. So Krithi Ramamrithan, who some of you might know from IIT Bombay, is an old faculty member from my graduate days. And he was very excited about telling me that on mobile devices, he was able to do remote diagnostics for healthcare applications. All right? This was several years ago, but this is just one example. There are lots of examples of rural deployment of mobile devices and all that. Right? He was talking of application. I was extracting the abstraction behind his application. For me, the abstraction was a use case which had fantastic scale. I couldn't think of anything which would give me 30, 40, 50, 100 million in terms of a test bed. For him, it was a non-issue. He's looking at the usability aspect of how to deploy technology. I'm looking and saying, but hey, you're talking about scale. You're talking about heterogeneity, because now you're telling me you have high-end devices, low-end devices. And you're talking about usability. You want uneducated people in some places only using icons or something to be accessing that information. For me, if I extract all of these things from a technology viewpoint, it becomes a fantastic use case, which I cannot duplicate anywhere in Europe or the US. Now, if someone takes, let's say, a security profile, all the heterogeneity in this particular test, in this particular use case, so what's the heterogeneity? You have low-end devices, high-end devices. You have energy problems in the rural areas based on which your network might connect or disconnect. A network connecting or disconnecting is actually a threat model. If your device runs out of power, it's actually a threat as far as a security person is concerned with. It's a use case. But the use case to a European to say the interest is to have portable devices looking at healthcare in the rural area is not going to excite anyone. But all this technology behind it is a common language we all talk. And if it can be reduced down to use cases and test beds which come along with it, that's a winner. And this is where I really emphasize for people interacting. By the way, I'm not using collaboration only in the Indian sense. Within the EU, we have 26 countries plus Israel plus China plus many other. The same analogy appears when somebody from Romania, Bulgaria, Hungary comes and says, wow, this is wonderful technology we have. But what's the value from a technological viewpoint? So now if you put my talk in perspective, I did not advocate any single specific technology or application theme. All I advocated was the fact that if you start thinking at the level of frameworks, whether it's the Internet of Things or cloud or whatever you would like to add, technologies come pretty naturally. But what frameworks help you assess is phrasing of lots of questions which do not appear if you're only dealing at the technology level. So questions about data ownership, liability, accountability appear because the cloud ecosystem is now a global framework which spans different national boundaries and the others. It's the nature of the framework that generates lots and lots of problems and solutions along with it. So I'm going to stop at this point, but I'm going to, anyone who has an interest in collaboration aspects, point you to an activity which will take place in November. This is where the European Commission will roll out the so-called Vision 2020 and articulate all the technology areas they want to go after. So thank you.
I think you were distinguishing that we should collaborate in technology, I think is well taken. On the other hand, I think I see a two-phase kind of a thing. One is a long-term where I think this technology is the base. That's what you like to develop. But in order to create interest, I think the local applications are what you using a framework, of course, but local applications, I think they excite people.
You know,
like Kriti did, as you said, or any other thing. Taking a specific example, say in agriculture or healthcare,
right.
doing it at a certain level still excites a lot of people, at least here.
Yeah, absolutely. So I did not explain this particular word. Use your local interest as scenarios, but show what technological depth they add. After you have collaborated at a technology level, you can certainly shape it back to your application. You're not going to do a project if it doesn't excite you. For you, the excitement is your local application area. But don't use your application area to excite the other side. Extract the technology elements from that application so you're talking a common language. And that common language for me is the use case where I extract. So the Kriti example I used was, for him the application is the driver. For me, scale, heterogeneity, and usability that he's doing in that application is the key driver that I can take somewhere else.
Yeah, in the particular project we had with Kriti, it was the other way. The technology was